Okay, guys, so chapter 8 is, if I recall, the title is probably Rational Expressions. And if you think about what rational expressions are, what is something if it's rational? It can be expressed as a fraction, right? So this chapter is about rational expressions, which means when we get to the second half of the chapter, we'll be working with, a lot with those rational expressions. The first half of the chapter, we are going to spend a couple of days looking at the graphs of rational expressions. In other words, when there's a fraction, how we graph it and what those graphs look like. Okay? And when I'm talking about rational expressions, I'm not just talking about, there's a 1/2 in it, like a number. I'm talking about rational expressions where there is a variable in the denominator and what those look like. Okay? So, you've definitely learned about direct variation before. My guess is you would have learned about inverse variation at some point too, but that is also one that sometimes gets skipped. So we're going to kind of review direct variation, make sure you guys know a little bit about inverse variation and what these relationships are. So direct variation. The phrasing you'll see is x varies directly with y or x varies directly, what's it say here, as y. Okay, so that indicates direct variation. Our common equation for direct variation, y equals k times x, where k is what? It says k is a constant. What do we mean by a constant? Represents some number, right? Some constant number. So when we talk about direct variation, y equals kx. Now, there's a variation of this equation we'll also use. We'll use this y equals kx a lot. But if we solve this equation for k, what does it look like as we solve this equation for k? If you were to get k by itself, we would have to do what? Divide by x, and k would be equal to y divided by x. So we'll use both of those equations in reference to direct variation. Y equals kx or k equals y over x, depending on if we're trying to find the k value or if we're trying to write an equation. Okay, so direct variation, there's that multiplication relationship. It's a constant times the x variable. Inverse variation. Well, wording, you're going to see given x varies inversely with y or given x varies inversely as y. The typical equations we see, the most typical one I would say is y equals kx. That relates to, I just said y equals kx, didn't I? Okay, y equals k over x is what it says. That's what it's supposed to say. I think I just spoke wrong there. But, so y equals k over x is the common inverse variation. Notice, instead of multiplication relationship, it is a division relationship. So it's your constant number divided by x, as opposed to direct, that is multiplication. Now, the other one that you would commonly use is if we solve this for k. If it's k divided by x, in order to solve this for k, you would multiply the x over, and then it becomes k equals x times y. That is the other common one you'll use. Okay, so on each of those would be the two I would focus on. Now, there is a third one there, and on your notes there's a typo. It should say, you'll notice it's already corrected on my notes, but it's x equals k over y. If you notice your notes say x equals k over x, what happened to the y? We need a y in there, okay? So that is another equivalent equation. I'll be honest, we don't usually use it though. Okay, but it is an equivalent equation that could work depending on the situation. Okay? So basically we talk about the equations if it's a y equals equation or how we find k. So if it's k equals. Now, one of the basic things you're going to be doing, and you've done this before, is taking a chart of numbers or a set of relationships there and determining, is this relationship a direct variation, an inverse variation, or neither of those? And then if it is direct or inverse, then we need to write an equation for it. So thoughts on A? How can I determine if this is inverse variation, or if it's direct variation, or if it's neither? Okay, plug the numbers into the equation, and that's kind of the gist of what I would agree with. What I tend to do is I tend to look, in order for this to be direct or inverse, there has to be a consistent K value. So, for instance, on, which one is it? On the inverse. Notice what it says for inverse. Inverse, it says x times y equals k, right? So, if this is inverse, every x times their corresponding y is always going to equal the constant k value. And that k value doesn't change from one ordered pair to the next. It would have to be constant. So what do you notice in this case? If we try that first pair, 2 times 10 is 20. If we try the second pair, 4 times 8 is 32. What do we know? Did I get a constant k value? No. So what's that say right there since I used the idea of x times y equals k? This is not what? Right now I know that this is not an inverse. Just because x times y did not always give me the same k value. Tell me, is my orange pen color showing up okay from the back especially? Okay. Tell me if you're not. So we know it's not inverse. Now what can we check? Is it direct? And if it's direct, what's the equation for k? If you look up above, it was k equals y divided by x. So what do? You take all of your y's divided by their corresponding x's and test it, right? So the first set is going to be what? 10 divided by 2, which is 5. Okay, what's the next set? 8 divided by 4. And what's 8 divided by 4? Do I need to keep going? No. What do I know right now since 5 and 2 are not the same? Okay, it's not direct variation. If it's not inverse variation and it's not direct variation, then it is neither. And that would be your official answer on this problem, is that it is neither. If it's neither, we can't find a k value, we can't write an equation, we're done right there. Okay, unless you guys have questions, moving along to B. So B, new set of ordered pairs. Thoughts? Do my numbers always divide to be the same? Do they always multiply to be the same? What do you want to try? What do you see just by eyeballing it? It looks like the numbers might, notice I say might, multiply or divide to be the same. Looks like they might multiply. Let's check it out. Now, keep in mind, it has to happen for every single set of ordered pairs, right? So, I'm going to check and see what x times y is. So, what is 2 times 15? 30. Here's the one you're probably questioning. What is 4 times 7.5? Oh, 30? Well, that kind of makes it good from there. What's 10 times 3? 30. What's 15 times 2? 30. Okay. Because x times y just always multiplied to be the same number, is this direct or inverse? Yeah, where was the equation up above xy equals k? Under inverse, right? So because x times y equals k, we know for sure that this is an inverse relationship. Okay? So what is k? K is 30. And I don't think in this particular setup it specifically said find the constant, find k, or, didn't ask us to state it, but it does say write function models for the direct and inverse variations. Thoughts on what you could give me as an equation? If k is 30, go ahead, Carter.
Do you want specific numbers or x and y?
We're using x and y when we write the final equation.
So x and y equals 30.
Okay, that works. Okay, now, and here's what I'm going to say. I was in a rush this morning when I sat through Math Excel, so I didn't actually go in and double check which way they want this, but is this an equation that represents inverse variation? Yes, this is an equation because inverse, we talked about xy equals k, xy equals 30. Now, what if they require it to be y equals, which I feel like they might? What's an equivalent version of this that says y equals? Okay, y equals k over x. What is k in this situation? 30. So I'm going to write y equals 30 over x. I'm not going to argue the fact both of those equations we just wrote represent inverse variation. But when they ask for that situation, write function models for the direct and inverse variation, usually they want the y equals. Okay, so I'm pretty sure that's what you have to give like in a Math Excel situation. Now, keep in mind, if you did x times y equals 30, right? X times y equals 30, we found that out up here. You could take this and solve this for y, right? If it's x times y, how do you get y by itself? You're going to divide by x. And so 30 divided by x. So it's not like you even have to have the chart up above to find that equation. Questions about expectations there or anything? Okay. What do you see on C? What are you trying? Because I know most of us can probably kind of eyeball that to begin with and saying, okay, well, multiplying definitely doesn't work or division definitely doesn't work, so let's try the other. Although there's decimals, so that might be throwing you off, but you guys have access to calculators, so you can't complain. What are your thoughts? Are these multiplying or dividing or neither? Dividing, maybe? Okay, so let's try it. If we're going to try this as dividing, then the idea is k is going to be equal to, which way do we divide? Y over x. And I get it. If y divided by x gives me a constant number, so does x divided by y, but it won't give you the right k, and that's important. So let's check each of those. In the first set, y divided by x, so 8 divided by 0.2. What is 8 divided by 0.2? 40. Okay? What about the next one? 20 divided into halves. How many halves are in 20? 40. Ooh, can you handle this next one? 40 divided by 1.0. Or in other words, 40 divided by 1. And what about 60 divided by 1.5? 40. Ah, what did we just find out? K is 40, yes? Y divides by x always gives me 40. So we know k is 40. Is that k of 40 represents inverse or direct variation? Direct variation? Look at the equations up above, right? Over here. If y divides by x is always the same, that falls into the direct category. We found 40 by doing what? By doing y divided by x, right? Every time I did y divided by x, I got 40. So that's one equation. What is the y equals version of this equation? Y equals 40x. You can go back up top and look, and it says y equals kx, so y equals 40x. Or if this is y divided by x, well, can't you just multiply it over? Are we getting the idea? You've kind of seen an example of each here. What do you notice on D? Oh, question, Jaden? Can it be direct and inverse at the same time? No, not possible. Okay. What are your thoughts on D, folks? Multiply. 0.2 times 40 is 8. Half of 16 is 8. 1.0 times 8.0. And 2.0 times 4.0? 8. They always multiply to be the same number, so that makes this what? Inverse. And what's my final equation then? Y equals 8 over x. And I was going to say, you've got a 50-50 shot. It's either y equals 8x or y equals 8 over x, right? It's just a matter of which is it. So because it's inverse, y equals 8 over x. What about E? Dayton says he doesn't think it works. I mean, if I start looking, let's see. 2 times 10 is 20, but 1.2 times 12, well, that's going to be in something involving 144 and throw a decimal in there. So I can't multiply them to get the same. If I start dividing, 10 divided by 2 is 5. That's easy, right? I'm picking easy numbers. 40 divided by a half, well, that's going to be 80. It's not happening, is it? Okay. And again, you have a calculator by your side, right? I know I just did mental math, but don't stress about the mental math. You'll have a calculator by your side. Yes, you'll be allowed to use a calculator. So this is an example of neither. And again, pick some numbers, try them all, whatever. You'll find that neither work here. Okay, you can handle when I give you a chart? I feel like you've probably seen that before, so who knows? We might have done that first semester with direct. I can't remember at this point, but okay. The other big thing we're probably going to we're going to start looking at the graphs of these. Okay, so suppose x and y vary inversely, and x equals 4 and y equals 12. So kind of a reverse situation. They are flat out saying x and y vary how? Inversely. They're telling us the relationship. Okay, so we're going to have to look at how to write an equation there and how to graph it. Now, do you guys remember anything about direct variation? Because I feel like we did that first semester. Maybe we didn't. If it's y equals, well, just, okay, think with this. If it's y equals kx, so y equals a number times x, what is that the equation of if it's direct variation? So y equals 2x, y equals 3x, y equals 20x. What does that equation look like? Is it like y equals mx plus b? Just the b is 0? Okay, if you remember direct variation, y equals mx plus b is the equation of a line, right? Slope-intercept. It's just that the intercept is always at 0. Okay, Well, now it's y equals k over x. So we've got to deal with, okay, what's that fraction do for us? And that's what we're going to look at here. So, suppose x and y vary inversely. X is 4 when y is 12. So, part A kind of walks us through this. What function models the inverse variation? In other words, I want to know y equals what over x? Right, so y equals k over x. How do I find k? Because I don't want you to just tell me k, though. Okay, so if you go back up top and look, inverse variation. I hate to slide the paper around, but I'm going to. What's it say up here for inverse variation? How do we find k? X times y. So, how do I find k down here? X times y. Did they give me an x and y value? Certainly did. So 4 times 12 equals k. 4 times 12 is 48. So this tells me that k is 48. If k is 48, what's an equation here? What'd you say?
4 equals 48 over 12.
Well, not an equation with all the numbers, but like an equation that represents this situation.
X equals k over y. 4.
Okay, except use the y equals instead of the x equals.
Oh, y equals k over x.
And what is k?
48.
48? So when you give this equation, what function models the inverse variation? We're looking for y equals 48 over x. Now, what's the other function that also models this? Could you possibly say xy equals 48? Okay, those are both true. Okay, and I'll accept both depending on the situation of what you're asked, how you're asked. Typically when we graph though, you know, we kind of tend to think about this, and I'm going to refer to both of these when we graph. But xy equals 48, we just found it this way, right? Solve for y, you can divide by x. Questions? I know there were some hands up. Did I get them all answered? Abby?
How do you know which equations to use in the way, like, we use different equations for the answers? Or
What?
You said there's like a 50-50 shot on which equation.
Well, as in, I mean, like in Math Excel, they'll probably tell you, or they'll say like y equals, and you have to fill it in to know like which equation to put in. Okay. In this case, like in terms of starting this problem, in order to find k, the easiest way to find k is to use the one that is k equals, right? Which was the xy equals k, or k equals xy. When it comes to writing the equations, honestly, I'll often write both. But more often than not, we use xy equals k to find k. And we write the final equation as y equals a value. I can't say always, but I'll, usually. Does that answer it? Maybe, maybe not. Okay. Other questions there? Okay. Let's look at the graph here. We talked about the graph of direct variation being a line, right? Always a line, every time. Well, inverse variation has a constant shape as well. It's not a line, though. So, in order to figure out what this graph looks like, we should probably look at one of our equations, right? We had two equations. We just talked about the equations. Y equals 48 over x. And we talked about the equations, or the equation, xy equals 48, correct? What do you do when you don't know what a graph looks like? XY chart is what I'm going to suggest, right? Now, on a typical XY chart, a lot of times we'll just do 0, 1, 2, maybe throw in a -1, -2. However, I'm going to take a different approach this time. Because if we just throw in 0, 1, 2, you won't get a good shape of what the entire graph looks like. Okay, so I'm going to take a slightly different route. And I'm going to use the idea of xy equals 48, which means when we start our xy chart, what has to be true about every set of ordered pairs? Every set of ordered pairs I fill into this chart. They have to equal 48. Yes? Okay. So I'm going to go in order. What is the first pair of numbers that multiply to equal 48? 1 and 48. Now I'll be honest, or do we really want to graph that? No, but I'm trying to set up a process here for you, okay? So just bear with me. We'll leave off graphing some of the extreme ones. So there's 1 and 48. 2 and what? 2 times 24 is 48, correct? Okay. 3 and what? There is a 3. 3 and 16. I'm getting more to something I might be willing to think about graphing here. 4 times something? 4 times 12 is 48. 5? No, we don't want a decimal. 6? 6 times 8? 7? Nope, again, we're not going decimals. 8? Now, okay, interesting point. We already have that one. In a way, we have that one, don't we? And I know, I shouldn't have written it down that quick. I should have waited to discuss this. But we do already have 6 and 8. But is 6 and 8 the same as 8 and 6 when we're talking about an ordered pair? No, because it's going to graph differently. And do we need that to see the entire shape of the graph? We do this time. So, now, continue listing ordered pairs with me. What's going to come after 8, 6? Can you use the pairs you already have? 12, 4. What's next? 16, 3. I'm running out of room. What's next? 24, 2. And 48, 1. Okay, so, to be honest here, I'm going to be honest. I'm not that industrious. I'm not going to graph 148 and 48, 1. I don't think I'm going to do my 24s either. Now, I am going to talk about the others because they'll help to give me a good shape. Not quite ready to graph though. What if I say we don't have all the ordered pairs we need yet? Negatives. Is there a way that we need to talk about negatives? And again, remember, this is our first graph. We can streamline this process later on, right? This is me just trying to get you guys to think about it. What about negatives? How do we get two how do we get negatives? How do we use negatives and we still have to multiply to equal positive 48?
Try 2 negatives.
Oh, maybe 2 negatives since I just gave myself away there. Okay, so, I already struck out 148 and 224. I said, I'm not doing those. Positive 3, positive 16, multiplied to be 48. What's an equivalent pair I need to consider with negatives? Negative 3, negative 16. So can I take all the ordered pairs I just have and do double negatives? Yeah. Yes. So it means I can use negative 4, negative 12, negative 6, negative 8, negative 8, negative 6, negative 12, negative 4, negative 16, negative 3. Yes, we kind of have a lot of ordered pairs to look at. But again, it's our first one. We need to talk about shape. Where are these ordered pairs going to fall in the graph? Where do my green ordered pairs fall? It's two positive numbers, so they're all going to fall in quadrant, top right quadrant, which is quadrant 1. Okay? Remember, 1, 2, 3, 4. Go counterclockwise, right? Does that sound familiar? So 1, left is 2, down 3, bottom right is 4. Friendly little review there. What about these double negatives? Where do they end up? Quadrant 3, or if you prefer, bottom left, right? Bottom left, correct? Okay. Now, notice the way this graph is set up. There's only one quadrant set up, and I should have, oh well. So what I'm going to do, just bear with me for a moment, okay? I have my plan, I promise. As in, I just kind of added my other quadrants. So that graph that's actually there, we're going to use that in this case all as quadrant 1. So let's graph in quadrant 1. The first ordered pair we're going to graph is 3, 16. So I'm going to do what? Right 3, up 16. Which, if I recall correctly, that's a 15 that's marked, isn't it? So right 3 and 1 above the 15. 4, 12. Right 4. Up 12. 6, 8. Right 6, up 8. 8, 6. Right 8. Up 6. 12, 4. Right 12, up 4. And 16, 3. Right 16, up 3. And obviously, if you wanted to think about the 148, 224, that type of thing, you could. Thoughts on what those positive values are going to look like? Not exactly a U.
Circle.
Quarter of
Yeah.
part of it.
Okay. Part of a circle. We're not completing the circle because think about it. If you had, say, 148, that would mean what? Right 1 and up 48. I just went up off the screen, right? So what we have here is a curve that is going to run up and right. As it runs up, it's going to get closer and closer to the y-axis, but never cross it, never touch it. And as it runs out to the right, it's going to get closer and closer to the x-axis, never crossing it, never touching it. What is the word to describe the x and y-axis? Asymptotes. Yep. Okay. So, and asymptotes is going to be a topic this chapter. So this is definitely something we'll have to work with. Now, there's my quadrant 1 graph, yes? What about those orange ordered pairs? Where are they going to be? Okay, they're going to do the same thing, but down here in quadrant 3. Now, I'm not taking the time to get precise on those, but what I am going to do is just kind of show you that you would have a curve doing something similar down there. Does that make sense? We could graph all of those ordered pairs if we had it all laid out and wanted to take the time, but I'm not. Are we okay with that? all of these inverse variation graphs will always have this shape. Two curves in opposite, I should use the word opposite, diagonal quadrants. Okay, so should be in quadrant 1 and 3, or maybe in 2 and 4. We'll look at that. But it's always this shape. It's called a hyperbola, reciprocal function. Okay, we need to answer part C. Got my screen back. Thoughts on how to answer part C? What is y when x equals 10? Carter?
Can we just go back up to the top and take that 48 divided by 10?
I would. Can we just go back up to the top? In other words, we had this equation up on part A, yes? Can we just use that? Most definitely. So if it's y equals 48 over x was my equation, this says what is y when x equals 10? So 48 divided by 10, which is 4.8. Now, I don't know if anyone was thinking it. If we wanted to be technical, could we use the graph to find that point? We could, but it wouldn't be very specific, would it? Okay, it would not be very specific. So, okay. I really thought we would get through the example on the top of the back side, but totally estimated my time wrong. Okay, so tomorrow, when we walk into class, I will most likely have you start by trying to work on example 1 at the top there. Okay, suppose x and y vary inversely and x equals 8 and y equals 7. So trying to work yourself through the process there. And then we also need to talk about combined variation. I have made the Math Excel assignment available, but as you guys can guess, it won't be due till Thursday. Today is Tuesday, so I'll finish notes on Wednesday tomorrow, and it will be due on Thursday. Got it?